when we discussed the spherical geometry, we had this spherical Pythagorean theorem, but when we took the sides of the triangle, of the right triangle, to be small compared to the radius of the sphere, then you saw that in the approximation we obtained the classical Pythagorean theorem. So let's see if we get the same thing here for the hyperbolic plane. So I'm going to assume that A, B, and C are small. So we'll assume A, B, C are small. So definitely smaller than 1. So I'm going to use, again, like I did in the spherical case, I'm going to use Taylor series. So we have, remember cosine, so the hyperbolic cosine, this is not good anymore, hyperbolic cosine of x, that's e to the x plus e to the minus x over 2. E to the x. Okay, so let's use the Taylor expansion here. So we get that this is equal to 1/2. So I'm going to use the Taylor expansion of e to the x. So that's 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4 over 4 factorial and so on. Minus the same thing, but when I replace x with negative x. So that's going to be 1 minus x plus, well, minus x squared gives you just x squared. But minus x cubed gives you minus x cubed and so on. Alright, so if you do the calculation, you see that the odd powers just go away, and all you're left with are even powers. And in fact, they're always double. Right, because there's 2x squares, 2x to the 4th on both sides, and so on. Okay, so that means that they cancel with the 1/2, and we get 1 plus x squared over 2 factorial plus x to the 4 over 4 factorial, and so on. The point is, if x is small, already taking the first 2 terms is a good approximation. Okay, so let's now see what we get. So if we look at cosh C equal to cosh A, cosh B, we get that cosh C is approximately equal to 1 plus x squared over 2 factorial over 2, really. Sorry, not x, but C in this case, is equal to 1 plus A, sorry, I forgot the square, right? It's a C squared. A squared over 2, 1 plus, that's all approximate here. So this is approximately equal to this as well, b squared over 2. Okay, so we just now focus on this equality. So this is then equal to 1 plus a squared over 2 plus b squared over 2 plus a squared b squared over 4. But this again is small, because if a is small, then a squared is smaller, and b squared is also smaller than b, a lot smaller. When you multiply these together, this is actually a term that whose degree is 4, so it's small compared to the other ones. So this is negligible. So we get, and I cancel the 1s on both sides. So we get that c squared over 2 is approximately equal to a squared over 2 plus b squared over 2. So c squared is approximately equal to a squared plus b squared. So again, for small hyperbolic triangles, the Pythagorean theorem resembles the classical one. So if you take small hyperbolic triangle the lengths have to be much smaller than 1, and you just compute their length, the hyperbolic length, then the hyperbolic length of c squared is approximately equal to the hyperbolic length of b squared plus the hyperbolic length of a squared.